So now that we've covered many of the operators in RxJava, it's time to take a look at how the AsyncTaskBarrier framework is implemented. We've talked about AsyncTaskBarrier. I showed some examples of where it's used when you register methods under test to be executed and to have multiple asynchronous operations running in the background without having the main thread of control fall off the main. So let's talk about the AsyncTaskBarrier API, which is available in all the test programs in my various utils folders in these reactive, observable, and flowable tests and so on. So first we'll talk about how the API works, and then I'm going to show you a cool test program that illustrates how to actually make this stuff work. So we'll see how to use it in practice. So recall that the AsyncTaskBarrier API contains 3 or 4 methods that are used to register, unregister, and then asynchronously run tasks. You can also run tasks synchronously, but that's really not the main use case this is designed for, although it still works. So some of the methods it provides are used to register and unregister tasks. Tasks are defined as suppliers that return completables. And we'll see in a second why they return completables. So as long as you have a method that's going to return a completable, you can pass it as something to the register method. As long as you have a method that takes no parameters and returns completable, you can pass it as a method reference to register or unregister. When you do that, as we'll see when we look at the implementation, those methods store the parameter into a list of suppliers to completables. No real surprise there. It's called stasks, S for static, so it's a list of static tasks. And then the method that's used after you've registered a bunch of stuff is the runTests method. And this method is the method that actually runs all the tasks that are registered, which can then run synchronously or asynchronously. Notice how runTests returns a single to a long. The long, of course, will indicate how many tasks ran successfully, and the single is used so that you don't require this to block. Now, you can call blockingGet on the single if you want when you need the result, but you could go off and do other things if you wanted to. So basically, this way, by using blockingGet with the single that's returned from runTests, you can ensure that the calling thread doesn't exit until all the asynchronous task processing is done. So let's talk about how to apply AsyncTaskBarrier in practice. And to do that, we're going to take a look at this example from the observable folder in my reactive repository in my GitHub repository. So here we are in the EX4 project in my reactive observables folder in my GitHub Live Lessons repository. And this is actually a really cool example, which we're not going to look at. Instead, we're going to go over and look at the tests program. And you can see tests is something that's going to have a bunch of unit tests that will exercise the AsyncTaskBarrier class in various ways. So I'll walk through this and I'll kind of show you what it does. A couple of things to note. Notice that I have annotated this method called testExceptions with the @test annotation, and that means we can run this as a JUnit test. Good practice if you're a Java professional developer or somebody who cares about your code working to use unit tests of some flavor. This is a JUnit test. There's other testing frameworks as well that you could use, but this is the one that's very commonly used. So here's what we're going to do. We're going to define a bunch of methods here that are going to do various things that will either throw exceptions or not. So here's an example where we have a method called synchThrowException, and this will intentionally trigger the arithmetic exception in a call. That is a synchronous call, not an asynchronous call. It's a synchronous call. And you can see what we're going to do is we're going to have a numerator that's 10, a denominator that's 0. That should be a red flag. We're then going to go ahead and emit the numerator, and then we're going to take the numerator and divide it by the denominator. Obviously, that's going to fail, and that's going to give us a arithmetic exception, and we put the doOnError action operator here, which will print the fact that an exception has occurred, and then we're going to use ignoreElement, which returns a completable, and that way it'll indicate to the AsyncTaskBarrier framework that this computation is done. Notice this is running synchronously. Let's now take a look at another example, which is going to intentionally trigger the arithmetic exception in an asynchronous chain. So once again, similar style. We have a numerator that's 10 and a denominator that's 0. We emit the numerator. We subscribe this to run in a single thread. Single gives you a single thread that'll run things in the background in that single thread. Then we do the divide operation in that background thread. That will cause another exception. We're going to display it. It'll say what thread it occurred in. It'll occur in a background thread. And once again, we ignore the element. So this is actually running asynchronously. By the way, just a little side note here, just so you understand the way this works. This numerator will be emitted in the assembly time thread, basically the thread where it was compiled, probably the main thread. And then the rest of the computations will be done in this background thread. If we had wanted to have the numerator emitted in the background thread, we could have used single from callable, and then it would have done the emission in the background thread. For this case, it doesn't really matter, but I'm just pointing it out for completeness. Then here's another example that will successfully complete synchronously. And what this will do is it'll multiply two values together, and that'll work. So it'll print it out, and we use ignore element to say we're done. And then we're also going to do the same thing asynchronously. So here we do 10 times 10. That will be run in the background, and then we're going to display the result. OK, so now let's go ahead and see how we can test all this stuff. So to test this, we're going to have this test method that runs when we run this particular JUnit program. And what it's going to do is it's going to make some supplier objects, sync throw exception, async throw exception, sync no exception, which are then assigned to these various method references. Then we register those things, and I'll explain why I did it this way in a second. The reason for this is so that we can unregister them correctly. So we create these local variables. We register those local variables with the AsyncTaskBarrier. We then directly register a method reference for the async no exception. Then we go ahead and take the AsyncTaskBarrier. We say, hey, run all the tests. Some will run synchronously, some will run asynchronously. AsyncTaskBarrier doesn't know, doesn't care, it does the right thing in all the cases. And then those ones that are asynchronous are going to go off and run in the background. The ones that are run synchronously will run in the same thread that the calling thread that is calling runTests. And then we say blockingGet on the single that's returned by runTests. So we're going to block this calling thread. And what should happen when this runs is only 2 tests should complete successfully. So we use a JUnit assert equals method. It's a predicate method. And we expect the test count, which is the value that comes back from runTests blockingGet, to be 2, because only 2 things are going to work. And we print out how many tests succeeded. It should be 2. And then we're going to go ahead and remove all but one of the tests being tested. And we do that by saying unregister, sync throw exception, async throw exception, sync no exception. And that's why we stuck things into these local variables up here so that we can unregister them there. Then we run the program again. We run the AsyncTaskBarrier again. This time, only 1 test should run and complete successfully, so we should get a value of 1. So now that we've taken a look at that, let's go ahead and see if we can run the tests. Do that. Do this. Run async barrier tests. And you can see it's compiling, starting up. Take a minute to compile it. It runs, and it worked. We get a green result indicating success. You can see that we have exceptions. These are the arithmetic exceptions where they occur. So you can see that we tried to divide by 0. And this is the one that runs synchronously. That's in thread 1. This is the one that runs asynchronously. It's in thread 19. That's that single-threaded thread scheduler that's passed into subscribe on. And then you can see that we also got results with the synchronous no exception in thread 1 and thread 19. So 2 tests were completed successfully, as we expected. And then, in this case, we got a no exception, which worked. And that also completed successfully as well. So test worked, got the results we wanted, demonstrates a couple things, shows how to use JUnit to write unit tests, shows how to use the AsyncTaskBarrier to register various tasks that will either run synchronously or asynchronously, and also demonstrates how exceptions work in the context of RxJava and asynchronous and synchronous programming.